of my life I was trapped in the dark. Is it daytime or night? I can't tell them apart. Baby, just to me. You're a child of the king, the great master is he, who will keep you from falling and suffer defeat. If you call on me in your greatest time, is it you?
Welcome back, grade 11s. We continue with our test. Now we are on question 2. We are doing question 2, which is a vector problem. So let me read you the statement. So the statement says a box is suspended above the ground by two forces F1 and F2 of magnitude 63,80 Newton and 53,50 Newton respectively. So F1 makes an angle of 50 degrees with the horizontal, and F2 makes an angle of 40 degrees with the horizontal as shown in the diagram below. So this is the diagram. So we have F1 is 63,8 Newton, and we have F2, which is 53,50 Newtons. This is the angle for F1, and that's the angle for F2. So this is the box. So the statement now says the box is stationary above the ground and all forces act in the same plane. What that means is that all of them, they act in the same plane. So that box has a weight which is towards the center of the earth. So we now going to look at our questions, and then we will see what is required of us. So we have F1, F2, and the weight. So let's look now at the questions. Define the term resultant. Define the term resultant. Now we know that a resultant is the vector sum. Resultant is the vector sum of two or more vectors. A resultant is a vector sum of two or more vectors. So let me write that statement in an answer book. So we say for 2.1, a resultant is the vector sum. Is a vector sum of two or more vectors. Yeah, a resultant is a vector sum of two or more vectors. That term there is very important. Yeah, now let's move and do question 2.2. So 2.2 now says draw a closed vector diagram. Draw a closed vector diagram for the above system. Show at least two angles. Show at least 2 angles. So now we have to draw a vector sum of this system, and then we must show 2 or more angles. So what is a vector diagram? So a vector diagram is something that looks like this, is a triangle of all 3 vectors, and these vectors are forming a resultant of 0 because they are in a closed system. You can either do it this way or you can either do it that way, but you must indicate at least 2 angles when you draw your vector triangle. So a vector diagram is a closed triangle, and the angles inside your triangle, the sum must give you 180 degrees. So we're going to draw something that looks like this or something that looks like that. This is a closed triangle. It's called a vector diagram. So going back now to our system. Now, in order for us to be able to draw a closed vector diagram, we need now to look at our system and see how these 3 vectors acting at the same point can form a closed triangle. Now, if you look at this system, you have 3 vectors. You have f1, you have f2, and you have f of g. So I'm going to, step 1, I'm going to extend fg, which is the weight. I'm going to extend it upwards. I'm going to extend it upwards like this, straight with the normal. Sorry for that. Let me show you. So I extend the f of g upwards. I did not change any direction here. The direction is still towards the center of the f. And then the second thing that I do, now look at f2. F2 is at the angle of 40 degrees. So what I'm going to do now, I'm going to form a parallelogram. This is f2. Let me create a space. So that is f2. Yeah, so this is still f2. Then f1 is moving towards this direction, 50 degrees. So I'm going to extend it this way, make it parallel with that side. Okay, let me just make it further up. So this is f1. It's also towards that direction. So I did not change any direction. They are still the same direction. So this is f2 this side. Then you have f1 that side. So this forms like a parallelogram. Yeah, so you form this parallelogram. So that's the first step that you do. You see we had f1 that side. Here is f1, same direction. Then we had f2 this side. Here is f2, same direction. Yeah, then there's an angle here which is an angle of 50 degrees, and it is outside my parallelogram. Now if you look now at this fg vector, this angle from FG will form 90 degrees with the horizontal. So if this is 90 degrees and outside here I'm having 50, that means inside here I should have 40 degrees, so as to make it 50. Similarly, on this side of F2, I have 40 degrees, and F of G is forming 90 degrees with the horizontal. So if this is 40, that means inside here I have 50 degrees to make it 90. So that's the second thing that you do. So let me take these angles out. So now we do have angles inside our parallelogram. So imagine you don't have this one now. Then we need now to get two more angles inside. This is triangle number 1, this is triangle number 2. So if this angle is 40 degrees, and you can see from your trigonometry, if you have two parallel angles and you have a transverse line cutting those two lines, we say this angle and that angle, they are alternate angles, and alternate angles are equal. So look at F1. F1 is like this. This is F1. So you have F1 parallel lines, and then you have this line now cutting in two. So that means the angle that is inside here should be equal with the angle that is inside here. So this 40 degrees is equal here. So this angle and that angle are equal because it's like you have a Z that looks like this. So this angle and that angle are called alternate angles, and they are equal. Also, if you look at F2, F2 is like this. So we had 50, that is here. It should be equal here. So this 50 is equal inside of here. So here we also have 50. So we have 50. Then below here we have 40. So this angle is 40 degrees. Yeah, so this is triangle 1 and that is triangle 2. So if this is 50 and 40, that makes 90. That means this should be 90, so that it makes 180. Also for triangle 2, if you have 40 and 50, that makes 90. You need 90 to make 180. So we have two triangles now. We can either draw this triangle or we can draw that triangle. So I'm going to take the triangle that is on the left. Now, if you can't see clearly, let me show you on the side. Yeah, so this is a triangle that I'm going to draw, which is this one, where you have F1, here is it. You have the weight towards the center of the L, then you have F2 at that angle. Then inside you have 50 degrees, 40 degrees, and 90 degrees. So this is the vector diagram that we are going to draw. So now let's draw this vector. So in drawing a closed vector diagram, we need first to have a scale. Now I'm going to take a scale of 10 newtons will be represented by 1 centimeter because your ruler cannot draw vectors like 63,80 newtons or 53,50 newtons. So we need to reduce now these vectors into a drawable single measured vectors. So if you divide 63,80 by 10 in centimeters, you're going to have something like 6,4 centimeter. If you divide 53,50 by 10, you're going to have something like 5.4 centimeters. So when we draw our closed vector triangle, the F1 will be represented by 6.4 centimeter. The F2 will be represented by 5.4 centimeter. So we can draw now this small
or vectors on a support. So the first thing now that you have to do, you take your protractor, and then you form a little Cartesian plane.
Just a small Cartesian plane so that you can have a point of reference. This is where we will start measuring our angles. So going back to your simplified vector triangle, the first thing that we will do now, we will measure this angle, this 50 angle. So we are starting here. We are going to measure this 50 angle. So you take the protractor, you point it in the inside. Okay. I can't pick it up. Okay, yeah. So the center must always be above your Cartesian plane. So we start counting 0, 10, 20, 30, 40, 50. So this is 50. This angle is an angle of 50. And we know which vector is that side. That vector is F2, this one. So we're going to start with this one, which is an angle of 50, is F2. So that's the one we start with. And what is the magnitude of F2? The magnitude of F2, we say, is 5.4 centimeters. So we take the ruler to draw a 5.4 centimeter vector. Yeah, that is 5.4. So this is F2. So I draw the arrow to show it's a vector. So it's F2, which is 53, 50. 53, 50 newtons. Then we draw again a small Cartesian plane at the tail of this vector. A small Cartesian plane at the tail of that vector. Now we need to find the angle, which is, according to your sketch, is this angle, which is 90 degrees. So now we're going to draw this angle, which is 90 degrees. So we take again our protractor, we put it on top of our Cartesian plane. So we measure for 90, 10, 20, 30, 40, 50, 60, 70, 80, 90. This is where 90 is. Now we need to draw now vector 1. And vector 1 is 6.4 centimeters. That is 6.4 centimeters. So that is vector 1. Here is an arrow. So this is F1, which is 63,80 newtons. Then where F1 ends, again we do a Cartesian plane. Now for FG, which we did not know, We did not know FG, so we simply join the two vectors. You can see now they are in line with each other. So you just simply join these two lines. Yeah, so this is 90 degrees. So now this becomes your FG, which you can measure with your ruler and then you can convert it back to newtons. So this angle there, remember we didn't indicate our angles. So this one we said it was 50 degrees. This one is 90 degrees. And this one is 40 degrees. We can verify this one. That's 10, 20, 30, 40. Yeah, it's 40 degrees. That's how we get our f of g. So this is your closed vector triangle, or is your vector diagram. And they said we need to indicate two angles. We did indicate this one, we did indicate that one. So this is what they wanted us to draw. So now we're going to check what else they want us to do. Okay, so 2.3 says calculate the mass of the box. Calculate the mass of the box. So there are two ways now to find the mass of the box. So remember, this is the vector diagram that we drew. So the first method to find the mass, remember the mass, here is the mass that we need to find. The weight is equal to the mass multiplied by G, which is 9.8. So we're going to use this formula now. F of G is equal to mg. We need to find that mass. But we don't know what is F of G. We only know G. So the first thing we must go now and find F of G. So we can use the sign, what they call it, the sign rule. So the sign rule says if you want this side, which is looking at this angle, you can equate it with any of the two sides that you know. For example, we know this side, which is f of 1, and f of 1 is looking now at that angle, which is 50. So the sign rule says the side which is f of g is looking at this angle, which is 90 degrees. And the side which is f1 is looking at this angle, which is 50 degrees. So that is a sign rule. You can either take this one, which is side 2, which is looking at this angle, which is 40 degrees. But I want to take f1, which is looking at 50 degrees. Then I'm going to cross multiply here. I'm going to say f of g, which is the side that I want, multiplied by sine of 50 degrees is equal to f of 1 multiplied by sine of 90 degrees. Then I'm looking for f of g, so I'll divide all of this by sine of 50 degrees. What I do on the left, I also do it on the right, sine of 50 degrees. Okay, so now I need to cancel out the sine of 50. Then I'm left with f of g, which is equal to F1, and we know what is F1 is 63,80 sine of 90 degrees all over sine of 50 degrees. So we must take the calculator now and check what is this value of Fg. On the calculator, so we say we have a fraction, we have 63,80 multiplied by the sine of 90 degrees, and then divide by the sine of 50 degrees. So I have 83,28. 83,28 newtons. So that is the value of F of G. So to find now that mass, then I say F of G, which is equals to mg. So the F of G now I know is 83,28. Then I say this equals to m multiplied by 9.8. So I divide this side by 9.8. I divide that side by 9.8. Then I take the calculator again and I check 83,28 divided by 9.8. So I have 8,50. The mass will be 8,50 grams. 8,50 grams. Now, here, you're not supposed to take two decimals first. You must write all that number that you got, then you divide by 9,8, then you get 8,50. That is the amount of the mass of the block. So I'm going to show you now the second method to find this mass. Yeah, so in the second method, if you don't want to use the sine rule, you can use your trig ratios. Now this is F1, which is at this angle of 50 degrees. Now a diagonal vector, we know it has two components. It has a horizontal component, which is Fx, and it has a vertical component, which is Fy. So I'll call this one Fx1 and that one Fy1. Now for vector number 2, which is F2, has an angle of 40 degrees. And this F2 also has two components, Fx, I'll call it Fx2, and it has a vertical component, which is Fy2. So now I want to find out what is my F of G. So I'm going to look now at the vertical angle, at the vertical vectors that I have. I have two vectors that are pointing upwards, and then I have one vector that is pointing downwards. So in this method, I'm going to take up as positive. Then I'm going to use my Newton's second law. I want to get this vector, which is Fg. So remember, they said that this is at equilibrium. All vectors are acting at the point. That means that the resultant of this is 0. So that means there is no acceleration here. The acceleration is 0 for angles that are at equilibrium or acting at the point. So that means that we have F net equals to 0. So F net now, I want the sum of these forces that are in the vertical. So I have Fy1, which is pointing upward, so it's positive. I have Fy2, which is also pointing upward, which is positive. Then Fg is downward, so I'm going to say it's negative equals to 0. So I want now this vector, which is Fg. So I have to find Fy1 and I have to find Fy2. The formula that we use is Fy1 sine of theta plus Fy2 sine of theta minus Fg equals to A0. So let's repeat again. We say we have Fy1 sine of theta plus Fy2 sine of theta minus Fg equals to 0. Now Fy1, which is the vertical component of F1, will be 63,80 sine the angle we said it was 50 degrees plus the second vector, which is F2, was 53.50 sine the angle was 40 degrees. Let's check again. Yeah, the angle of F1 is 50 degrees and the angle of F2 is 40 degrees. So we need now to check this on the calculator. So let's say now subtract Fg equals to 0. So we have to punch this now on the calculator and you have to punch that on the calculator. Okay, yeah, to save time, if you punch this in the calculator, you're going to get 48,87. If you punch this, you're going to get 34,40 minus Fg equals to 0. So we have to add now these two magnitudes of Fy1 and Fy2. Now we get 83,27. So we need now to take that value and put it on the right. It's going to be negative 83,27. So we divide by negative. So the value is 83,27 Newton. So is similar or equivalent to the value that we got when we use the sine rule. So now we have to say Fg is equal to mg. Then you know what you do. You put 83,27 this side. Then you divide that by 9.8. So you'll get the same answer, which is 8.50 kg. That will be the mass of the box. Yeah, now let's do the following question. Okay, so the last question now, which is 2.4, says force F2 is removed. What will happen to the net force on the box? What will the net force on the box now be? So if F2 is removed, what will be F net on the box? So that's what they are asking here. So imagine here you have something that looks like this. You have your F1 in that direction, you have the F2 in this direction, you have your weight in that direction. Now this one is being removed now. F2 is being removed with all its components and everything. So you don't have anything now for F2. The only thing now you have is F1. So if you only have this, your F net now, which we know is 0, will be your F of y. Remember, up is still positive. So you only now have Fy1 minus your F of g equals to a 0. So your Fy1, we calculated it to be, I think it was 48,80. You can verify on your calculator, 63,80 sine of 50 degrees. This side is 50 degrees. Then the weight, we calculated it to be, it was 83,28. Yeah, here is it, equals to a 0. So, yeah, your F net now will be that 48,80 minus this 83,28. If you punch this in the calculator, you're going to have negative 34,41 newtons. So the net on the box now will be negative 34,41, or you can say it's 34.41 Newton downwards, because up is positive and down is negative. Yeah, so this is the answer for the last question. This is the end of our question 2. Yeah, so now we are moving to question number 3.
All of my life I was trapped in the dark. Is it daytime or night? I can't tell them apart. I'm lost in believer. Just said unto me, you're a child of the King. The great Master is He who will keep you from falling and suffer defeat. If you call on Him, in your greatest time, is it you? I'm forever to sing every day. My morning sun, you are ever to smile. Is it